So we are going to look at exponential functions. Now we've looked at polynomials already, things that look like x squared. Now we're going to look at things like 2 to the x. Let's notice how an exponential function is different from a polynomial. Notice that the variable is the exponent. So we are going to see in an exponential function, the variable will be in the exponent. It will be the power. It will be somehow involved in the power. So notice here, the x is not the exponent. The 2 is the exponent. All right, now let's get a few pieces of terminology just for to help us when I refer to these things. The 2 in this case is called the base. And of course our exponent, x, we can call it the exponent or the power. And of course our exponent in an exponential function will have a variable in it. Okay, so exponent or power. All right, now we're going to first explore what an exponential function looks like if this base is a number greater than 1. So we're going to look at a base that is greater than 1. All right, so we can start with this 2 to the x if we so desire. So I'm going to go just to something that'll make our graphs prettier. I'm going to put in 2 raised to the x power. All right, now notice this graph. All right, now this appears to be touching the x-axis, but it's just getting really, really close. It never actually touches or crosses the x-axis. So we're going to list a few things here about this 2 to the x graph. And I want you to notice, like if I change this 2 to a 3, notice it looks very similar. Or if I change it to a 4, again, it looks very similar. It's just getting steeper as I change this base. If I change it to a 10, notice it got even steeper. So let's look at a few things, a few characteristics we need to be aware of. All right, so I'm going to use this little draw feature up here. And let's notice that for all of these, we had a base that was bigger than 1. All right, that was greater than 1. All right, and when that's true, there are certain things that are always true. I want you to notice this point. No matter which base I used, that point remained the same. So they all contain the point 0, 1. All of them do. And we'll find that's true when the base is less than 1 too. All right, so they contain 0, 1. Now, this one had 10 to the x, and I may need to adjust my window so that you can see this. Let's see if I can adjust the window here. Or I'll tell you what, let's change it back to 4 to the x over here. And it's not going to let me. All right, so I had to quit my little thing just to show 4 to the x. All right, so now I want you to notice this point right here. Notice that the x value here is 1 because this is actually being scaled by 2. This is the point 1, 4. All right, where 4 was the base that we put in here. All right, so it contains 0, 1, and 1, and whatever our base is. So every single one of these contains these 2 points, okay? Now this will be true even when we look at a base that is less than 1. All right, now, let's notice that really I said that this does not really touch the x-axis. It's just getting very, very close to it. So the x-axis is a horizontal asymptote. Now, let's notice this graph is always increasing. So it's increasing for its whole length. If we think about the domain of this graph, this right here is going out in this distance forever, and this is going up forever, which means it's slowly going outward, so it's going to the right forever. So this thing has a domain negative infinity to positive infinity. All real numbers. The range, on the other hand, you'll notice that it's never beneath the x-axis. So the range, and it never really gets to the x-axis, even though it looks like it is here in the picture. So the range is 0 to infinity. You just can't draw it real close without it appearing to be on top of the x-axis. But it's 0 to infinity. All right, now, that's what happens if our base is greater than 1. Now let's look at what happens if our base is a fraction. Now, I want to note that we will never have a negative base. So that's very important. We're not allowed to have a negative base, but we can have a fraction base. So let's go ahead and get out of this, and let's change our base to any fraction we want. I want you to notice if I put 1/2, whoops, doesn't matter, it's kind of, I don't think it needs the parenthesis there. There we go. Notice the shape of this graph. If I I'll change it to 1/3. All right, notice it looks very similar. 1/5, very similar. 1/10. Again, very similar. Now I'm going to go back to 1/2 just because it will be easier for us to see what I'm going to talk about. A while ago, though, I had some characteristics on here. They were all of these. Now let's change this because now we're looking at the base as, let me use my eraser, a fraction. So our base is a fraction, positive fraction though, that's very important. So it's some fraction between 0 and 1. Notice though, it's still going through 0, 1, that's still a point, and it's still going through 1 in its base. If we look right here, 1 in its base, this is 1 right here, that's 1/2. So this point is 1/2. So it's still 1 and its base. And actually, let me erase this point up here because that's no longer on the graph. All right, now, x-axis is still its horizontal asymptote. It looks like it's touching it, but it really isn't. It's just getting really, really close. But this graph, if we have a fraction, is not increasing, it's decreasing. So I'm going to change this to decreasing. So if we have a fraction for our base, the graph is decreasing. The domain is still negative infinity to positive infinity, and the range is still 0 to infinity. All right, so this is important. If we have a fraction for our base, we're going to draw a decreasing graph that goes through 0, 1, and 1 and whatever that fractional base is. If we have a exponential function where the base is greater than 1, we're going to draw that increasing function that goes through 0, 1, and whatever 1 and the base is. So that's going to determine which direction the graph goes. Fraction, it's decreasing. Base bigger than 1, it's increasing.